Yes.
Okay. Now I would like to speak about the energy policy and some energy strategies. The main objectives of energy policy are to coordinate and accelerate the energy transition, to phase out coal-based energy production by switching to renewable energy sources, and to reduce energy demand by increasing energy efficiency. Firstly, I would like to speak a couple of words about the Intergovernmental Panel on Climate Change. The Intergovernmental Panel on Climate Change was established in 1988 at the initiative of the United Nations Environmental Programme and the World Meteorological Organization, and endorsed by the United Nations General Assembly in a resolution on climate change. Its aim is to access and synthesize research findings on climate change caused by activities. It does not carry out its own research, but processes peer-reviewed scientific publications and summarizes their content in reports. This is a very interesting situation because this organization published three summaries per year, and this is 600 and 700 pages. After that day, the scientists create a summary, and this is 100 pages. After that, from this, create the politicians 30 pages summary, and this is other one which the scientists summary, and this is a very big problem. The next is the Kyoto Protocol from 1992. The Kyoto Protocol is the supplementary protocol to the United Nations Framework Convention on Climate Change, as finalized in May 1992 and signed in Rio de Janeiro in June 1992, which was adopted and opened for ratification by the third conference of the parties to the United Nations Framework Convention on Climate Change in Kyoto on 11th of December 1997. The protocol entered into force on 16th of February 2005 with the support of all major countries of the world except the United States and Australia. Under the protocol, developed countries committed to reduce the greenhouse gas emissions by an average of 5.2% below 1990 base year levels for the period 2012. This varies from country to country, with the original 15 EU countries committing to an 8% reduction. The former socialist countries were allowed to choose a base year other than 1990, taking into account the dramatic reduction in greenhouse gas emissions resulting from the economic collapse after 1989. For example, Hungary committed to a 6% reduction compared to average emissions in the period between 1985 and 1987. The protocol was promulgated in Hungary by 4 of 2007, the promulgation of the Kyoto Protocol to the United Nations Framework Convention on Climate Change, adopted at the third session of the conference of the parties to the United Nations Framework Convention on Climate Change. The next is the German Renewable Energy Act. The German Renewable Energy Sources Act regulates the preferential feeding of electricity from renewable energy sources into the electricity grid and guarantees fixed feed-in tariff for producers. Since 2000, it has gradually extended the previous Electricity Feed-in Act. According to the legal definition, it serves the following purposes in the interest of climate and environmental protection. To enable the sustainable development of energy supply, to reduce the economic costs of energy supply, taking into account long-term externalities and international internalization of external costs. Conservation of fossil energy resources and promoting the further development of technologies for the production of electricity from renewable sources. The next is, and this is a very important part of the energy policy, this is the Stern review from 2006. The Stern review was published on the 30th of October 2006. At the request of British Prime Minister Tony Blair, Sir Nicholas Stern, former chief economist at the World Bank and financial advisor to the British government, has produced an analysis of climate change and its potential economic impacts. According to the Stern review, the cost of mitigation could be as much as 1% of GDP, and if this is not achieved, global GDP could fall by up to 20% in the worst case. The Stern review is the first economically rigorous study of global warming. At 700 pages, the paper has been described as the most important document of Tony Blair's administration, claiming nothing less than that climate change is the biggest risk of the global economy, but also a great opportunity. It concludes that costly steps that can be taken today to prevent future major climate change will prevent 10 times the costs later. Spending 1 and 1.5% of GDP today to reduce carbon emissions would be sufficient to avoid future losses of 10 and 15%. The next is the Hungarian Electricity Act. Hungary also supports the use of renewable energy sources and waste as a source of energy. It aims to protect the climate, promote the use of multiple energy sources, increase energy efficiency, reduce energy dependency, and harness the effects of local economic development. One of the instruments to promote electricity generation from renewable energy sources and waste in the feed-in tariff chain, where electricity can be sold at a legally determined feed-in price above the market price. You can see on this picture the small-scale household power plants, the pieces of small-scale household power plants in Hungary. This is a very fast increase in this power plant category, and there is a very big problem in Hungary that we have today a lot of overproduced electricity, and our network cannot store this electricity, and we don't have electricity storage capacity. Renewable electricity production from new investments is supported by the renewable energy support chain. This is the METAR system. METAR is a green premium type chain where support for new investment can be applied for in the form of an entitlement laws through a tendering procedure. Under the premium chain, the producer sells the electricity himself and receives the subsidy above. Renewable energy should be encouraged not only for large energy producers and businesses, but also for the general public. To this end, the Hungarian Electricity Act provides for the possibility of setting up so-called household scale small power plants from 2008. Since then, this option has continued to enjoy unbroken popularity, with the number of power plants reaching more than 140,000 in 2022 and installed capacity reaching 1,200 megawatts. By comparison, this is equivalent to 60% of the capacity of the Paks nuclear power plant, which accounts for half of Hungary's electricity generation. Nearly 100% of these household power plants are solar power plants. Topic of this chapter is the Paris Climate Agreement from 2015. The Paris Agreement on climate change, or just the Paris Agreement, is an agreement by the members of the United Nations Framework Convention on Climate Change to reduce greenhouse gas emissions, adapt to global warming, and address its financial consequences from 2020. The agreement was negotiated by representatives of 195 countries at the 2015 United Nations Climate Change Conference and adopted by Congress on 12th of December. As of September 2018, 195 member states had signed the agreement, of which 185 have become members. Under the Paris Agreement, each country sets its own contribution to mitigating global warming. Objectives: to keep the global average temperature increase well below 2 degrees Celsius, above pre-industrial levels, and as a continuation of efforts to keep the temperature increase below 1.5 degrees Celsius, above pre-industrial levels, recognizing that this will significantly reduce the risks and impacts of climate change. Increasing the capacity to adapt to the adverse effects of climate change, building resilience to climate change, and promoting low greenhouse gas emissions development by not threatening food production. Ensure consistent financial flows towards low greenhouse gas and climate resilient development options. The next part of this issue, the emissions trading chain. The EU's main climate protection instruments for the industrial and energy sectors is the emissions trading scheme. The scheme aims to limit emissions from different sectors. The amount of carbon dioxide that can be emitted is reduced each year, and companies are obligated to reduce the emissions through energy efficiency measures or to buy carbon credits, also known as allowances from other emitters. Environmental tax policy. Environmental tax policy taxes environmentally damaging activities, such as the consumption of fossil fuels. Environmental tax revenues can be used to reduce the cost of what society considers to be good. This policy has been introduced with great success in many countries, creating hundreds of thousands of jobs by reducing fuel consumption and making the workforce more competitive internationally. The next policy is the Combined Heat and Power Act. For a power plant to operate economically, that heat produced must be used not only to generate electricity, but also to produce heat for heating of industrial use. To spread this efficiency, the Combined Heat and Power Act was created, which provides price support for cogeneration, depending on the size of the system, regardless of the fuel. Energy efficiency support. Approximately 40% of total energy consumption is used for buildings, mainly for heating. Energy efficiency support aims to reduce this energy. Several countries have invested heavily in the development of so-called passive houses, which do not require active heating. This is due to the design of the building, very good thermal isolation, the use of renewable energy, and the heat emitted by the occupants and household appliances. The next is the feed-in tariff system. The feed-in tariff is a policy instrument designed to accelerate investment in renewable energy by offering producers long-term contracts of 15 and 20 years. It aims to provide access to the grid and guaranteed price for energy from renewable sources above the market. Above the market price. This will make it predictable, which will help finance investments in renewable energy. And finally, this is the green certificate system. The green certificate is a tradable good that certifies that certain electricity has been produced using renewable energy sources. So this part was the energy policy and strategies around the world. And the final part of my presentations is the energy storage and transportation. Do you have maybe any questions? Okay, you can see on this first figure the comparison of various energy storage technologies. Some storage technologies can be store the electricity or heat short time period, but the other ones can be long, can be stored the electricity and heat the long time period. You can see this on this picture. For example, batteries can be stored energy between 1 and 7 days, and in hydrogen and methane we can store the electricity and heat power more than 1 year as well. The first technology is the water pumping energy store technology. We have down lake, the upper lake, and between these lakes can be transport the water. And if we have overproduced electricity, for example, from wind energy or solar energy, we can pump with this cheap energy the water from the down under lake to the upper lake, and so can be storage the energy. And if for example, the cities or the consumer have a demand to the for the short fast electricity, we can let this water during the turbines to the down on the lake, and we can produce electricity after 2 minutes. For example, in Austria, there are a lot of water pump store power plant, and for example, in Hungary, we have a lot of overproduced electricity from the renewables, solar power plants, and from the nuclear power plants, and this cheap electricity by Austria, and pump the water to the top of the Alps, and in the morning give this electricity back, but the price is 5 times. You can see on this picture from Canada, from the Niagara Falls. And this is another one from Switzerland. This is a large pumped storage hydroelectricity reservoir in the Alps, and they can produce so many. They can store so many electricity than 400,000 electric vehicle batteries. You can see on this picture pumped storage hydroelectricity reservoir from Gran Canaria. This is a very interesting system because they have a lot of overproduced wind energy, wind electricity, and they desalinate the seawater with this overproduced electricity. They stored this fresh water near the coast in a lake, the freshwater lake. After that, if they have more overproduced wind energy or solar energy, they pump this water in the upper lake, and they store there. After that, if they have for example, from Las Palmas come the electricity demand, they can produce fast electricity to the city. And so they have electricity storage and fresh water as well. The other technology is the compressed air battery. You can see on this picture. For example, by us in the Faculty of Engineering of the University of Debrecen, the mechanical engineers build small cars. You can see on this picture, and they go with these cars to racing, and the topic of the race where can drive with one air battery the more what is the name? Distance. Thank you. The next technology is the electrochemical battery. Researchers at MIT are developing an electrochemical battery. They say can offer grid-scale backup for renewable power sources with consistency like soft serve ice cream. The semi-solid flow battery uses the positive and negative ions of different chemicals to change and store energy. The next technology is the Flybrid kinetic energy recovery system. This is not new technology, but this function very good. And if we want to store the electricity for a short time, we can use this technology. The next technology is the district heating accumulation tower. You can see on this picture the district heating accumulation tower from Theiss, near Krems, under Donau in Lower Austria. Here in this system stored not electricity but heating, heat. The next technology is the rechargeable battery bank, which is used as an uninterruptible power supply in a data center. You can see here the Tesla technology. They are three technology types. The one of these, the power wall. You can see this on this picture. So this is a very simple box, and we can store in this box 4 or 5 kilowatt hours electricity. For example, if we have a solar power plant in our roof, and we have overproduced electricity, we can not pump to the network, but we can store at home. For example, in Hungary, from last week, we cannot pump the household overproduced electricity to the network, because the network use more electricity, and we have to buy these batteries, but these batteries today are very expensive. For example, this simple Tesla battery is 7,000 euros. This is so expensive that 5 kilowatts solar power plant.
Okay.
And the other one for the companies or schools or residential areas. This is the power pack. This can store between 100 and 200 kilowatt hours electricity capacity. And the biggest, the mega pack, this can store 3 megawatt hours store capacity from electricity. This can use, for example, small cities, villages, or big companies, for example, BMW. Company in Debrecen, for example. Okay, the next, the concrete power store. This is a very interesting idea from Switzerland. American Swiss startup, the Energy Vault, designed a giant mechanical energy storage system that uses gravity and 35 tons bricks to store and generate energy. In this prototype, crane powered by surface electricity raises the bricks and then lowers them to release kinetic energy back to the grid. Now Energy Vault is exploring how to scale up its technology. Instead of towering cranes, the company is pivoting to resilience centers, as shown in this rendering, in which the bricks would be moved up and down on trolley systems controlled by artificial intelligence. You can see this technology on the pictures. And we can store a lot of electricity in the vehicles, for example, buses. Full electricity buses, they are in Debrecen city as well. I come from this city, and this work very good today. The next, the battery storage system combined with the gas turbine. This is technology. This helps reduce greenhouse gases and operating costs at two exiting Baker plants in Norwalk and Rancho Cucamonga. The 10 megawatt battery storage system combined with the gas turbine allows the Baker plant to more quickly respond to changing energy needs, thus increasing the reliability of the electrical grid. The next is the molten salt usage. The usage of molten salt in thermal energy storage applications has become more common. In commercial solar energy storage, molten salt is used in conjunction with concentrated solar energy for power generation. Molten salts are able to absorb and keep heat energy transferred from the fluid mediator, then to transfer it again when it's needed. In the liquid state, molten salt has a similar state to water. It also has the capacity to retain temperatures of 1000 Fahrenheit. Through efficiencies known to be lower than often storage media, such as batteries, the main advantage of the usage of molten salt is lower costs, which allows the technology to be implemented in a higher volume production. Okay, the next, I think this is the last technology, the sand battery. Finnish company Polar Night Energy has installed the world's first fully functional sand battery, which stores energy generated by solar and wind power as heat in a insulated silo packed with 100 tons of sands. I think this is a very interesting and very popular electricity or heat store system. For example, I think this technology can have a very good use in the Middle East or in North Africa. Okay, and the last sharing of overproduced renewable energy between countries. Building giant batteries isn't the only way to manage renewable energy demands. Sharing electricity across long distance using interconnectors can help countries move power when production exceeds local demand. For example, renewable energy in the United Kingdom comes predominantly from wind, while in Norway, hydropower is the main source of clean electricity. The $1.6 billion North Sea Link project, which launched last year, will allow the two countries electricity and balance out the varying supply of each renewable energy source. I read a very interesting example from Germany. There is a village in the middle of Germany, and in the area here located soldater, American soldater storage, and there are a lot of buildings where store the weapons and guns, and the population of the village wrote a letter to the Pentagon that maybe we can use solar electricity on the roof of the buildings, and they built a lot of solar power plants, and they produce 4 million euros per year with the American Army. Okay, thank you for your kind attention. These were my presentations about renewable energy technologies, energy storage, and policy. Do you have any questions? Okay, then thank you very much for your attention.
Thank you.